This video is going to be showing you the differences between 3D planning and IMRT planning, as well as SBRT planning. It's not going to be too in-depth, but it's going to be more of an introduction as far as what you can expect. This first example I'm going to show you is an example of 3D planning. You may ask yourself, exactly what is 3D planning? 3D planning is going to be planning in 3 dimensions. It is also a type of forward planning. And what we mean by that is, yes, there are certain objectives that we would like to see in a particular plan, but the planner, whoever it is, dosimetrist, physicist, has to sit down and to manipulate the beams, the weightings, the modifiers, whatever tools are at your disposal in order to be able to get the dose distribution you're looking for. And any example here of a 3D plan, of a 3-field 3D plan, you're looking, this obviously is a phantom, you're looking at a target here. You've got these 3 beams that are put in, they're wired in at particular angles that you're typing in this case, to the Eclipse planning system. You're putting those angles in, and you're trying to figure out exactly how to cover this orange area here to a specific dose. Obviously, what you've got right here is a big mess, because you've got coverage that's just slanted up here, and then you've got dose that's leaking out here on the sides. And that usually comes about whenever you've got too strong of a wedge, both here and here, that is pushing the dose well over to the side. The isodose lines, the higher isodose lines, are going to shift from the heel to the toe, and that's why the wedge is there. In this particular case, what you want to do is you want to change the weighting, which is what this window is all about, such that you can go from a distribution of like that to something more like this, and hopefully maybe even something a little bit better, depending on how you adjust the degree of the wedges. Maybe you want to back off a little bit. You might even be able to adjust the energies of the beams that are coming in. You might say, maybe make this one a 6x as opposed to an 18x. You might take this one that's cutting through more tissue up here, and you might make that into a 15 or an 18, something along those lines. So by doing that and adjusting the wedge angles, you can produce a pretty good plan, something that's very, very conformal, so that's tight around this particular objective. So those are the kinds of things that you're looking at as far as 3D conformal. You're basically going to be drawing a block, which is a little hard to see here, but you're going to be drawing a block around the specific target that you see here from the view of the beam, as if you were riding the beam into the patient. What would you see? You'd set the block there, and then you try to conform your isodose lines around that. So that's an example of what you see as far as 3D planning is concerned. Again, you kind of know what you want to see, what your objectives are as far as isodose line coverage, trying not to streak through particular normal structures, things like that, in order to be able to get the coverage you're looking for. Head and neck planning, particularly what you're seeing now, is going to be an example here of IMRT planning. As you know, with head and necks, you've got several different targets, and then many more normal structures that you're trying to preserve the dose from reaching. And in many cases, you can't put together a 3D plan that's going to be able to produce all the things that you're looking for. So what you're going to do in Eclipse is you're going to go to the optimization window, and you're going to say, hey, I want criteria like this. I want criteria like this for that structure. For a different structure, I want a different criteria, different weighting, and things like that. And you fill all of that information in. It's almost like filling in a wish list. What is it you want to see out of this particular plan? Even after you've set up what the beam arrangements are going to be, what the beam energies are going to be or whatnot, but you're telling the computer, hey, I want you to be able to produce a plan that generates prescription dose of whatever amount to these volumes, and I want you to try to preserve the normal structures as much as possible. Then once you hit the optimize button, it goes ahead and it tries to figure out exactly how to accomplish this. This DVH right here shows you how well it's doing. It'll show you, maybe you've got the target structures and they're covering things really, really well. And the normal structures, if they were turned on, might descend over like this, or they might kind of creep along the side here or whatnot. It kind of depends on what type of structure it is, where it is, and how closely the isodose line is going to try to wrap around that particular structure. So that's what you're looking at here as far as IMRT is concerned. You're looking at filling in the target structures, which is using for Eclipse, you're going to be using a lower objective because you want to make sure that 99% or 100% of this particular structure is getting the prescription dose that you're looking for. And then the normal structures here are going to have either mains or uppers, things, upper constraints, in order to be able to try to limit what dose that they receive. And you can see here, as far as the cord is concerned, it's doing a pretty good job. So that's what the intensity modulated radiation therapy, IMRT, is supposed to do for you. Now, SBRT, what you are looking to do here is you're looking to concentrate a very high amount of dose in very few fractions to a specific target. You're trying to limit the amount of scatter dose to anything else around it within certain parameters. And as you can see here, you've got somebody who's got several brain mets that you're trying to hit all at the same time. Here you've got a lung, here you've got a spine, here you've got what may be an adrenal or something like that. And you're trying to hit these things with a particular, a number of fractions, 5 or less, and you're wanting to hit it with anywhere from 700 to 800 to maybe 1800 centigrade in a fraction, which is quite a bit. So you have to make sure that you're trying to preserve any sort of structures that are around it. Now, SBRT can be done with forward planning. We've done that in the past using several different static beams as well as conformal arcs, things of that sort, where you, the planner, are the one trying to set this up to get the dose distribution that you need. They can also be done using IMRT, where you're telling the system, you're putting in, just like with that head and neck, you're saying, I want this structure to get this amount of dose, but I want to limit it to others. And as you're putting in those parameters, you're trying to preserve those normal structures as much as possible. So I hope that's a pretty good synopsis here of these 3 concepts and what they mean as far as planning is concerned.